Hello and welcome to another full stack development tutorial. This time we'll focus a bit on AI. So if you remember in the last video, I showed you how to build a type-safe full stack application. And here on this slide, we see what we basically did. So we had a web app in the front end, and this was done with React and TypeScript. And type here was used to create the type safety for the incoming data, which is typically a JSON string. Now we had also a middleware, which handled the persistence of our data. So it was a very simple, fast API application with a Mongo database. And here we were using Pydantic. Pydantic was our single source of truth for defining the types of the API. And in this video, I showed how you can then generate the types for the front end from it. And those two components, Pydantic and type here, create a nice type safety between those two components. Now, if you bring AI into the game, so typically an LLM, what you'll have here between the middleware and the LLM, you'll exchange tokens. It's basically strings. So the real message you get back from a chat completions API, for example, let's have a look, is also an object, a JSON object, but the essence, the real result of your request is under messages, and there you have the content. And this is just a string or null. If you just want to write a chat application, that's fine, but there are also other use cases where you might want to have a structured output from the model. For example, you want a list of ingredients for some meal you want to cook, and you want to have the amount of every ingredient, and you want to have it not just as a text where the model is telling you what to buy. You want to have just a structured output. What you can then do, you can again use Pydantic here on the middleware side, and on the model side, you basically pass a JSON schema, and this schema can be used to then restrict the output of the model. And I'm going to show you in this video how to do this exactly. And the next step, if you go one step further, is instead of just using Pydantic and doing it by hand, so coding it yourself, you can use the new framework, which is called Pydantic AI. So this is an agent framework. It's currently in the beta phase, but it's a very nice framework for building agent applications. So not just a very simple request response type of application, but really chaining multiple agents. But in this tutorial, we'll focus on just one aspect of Pydantic AI, which is it ties in nicely with Pydantic because also it's from the same authors and provides type safety out of the box. The next step, I want to show you a little coding example where we go through the different steps, and you'll understand exactly how you can achieve this type safety and also how Pydantic AI achieves this. So what we have here is a little Jupyter notebook, and we have different experiments. So I've set this up with my open API key, and the simplest way to use the completions API is just create a user message here. We tell the LLM to say this is a test, and if we just want it to respond with this string, we also tell it output only what you ask for. Otherwise, it will always add a little small talk afterward. So if we run this, we get back a string. So that's the very typical use case, and this is what you could do in a chat application. So you just expect, here you see it, a string back from the model, so you don't need any typing. Now the next example, we want the model to create a groceries list. And here we now have two messages. The first is the role system. So here we're setting up the system, providing context for the model, and tell it how to behave. So what we're telling here, your grocery list generator, given a meal as input, you return a list of ingredients. The meal shall use whole food ingredients, so just some additional information. And you include the amount for each ingredient to prepare the meal for 2 persons, and use the metric system. So this is all the information we convey here. And then as user input, this is basically the variable which our application would have. So imagine you have some user input where you could just put in some meal, and our API would then return the list of ingredients to go buy them. So here, pizza margarita, let's just run it and see how the answer looks. And you see here, this is a typical LLM response. There's some introductory text. And then here, nicely formatted, I have to say, we have the list. So pizza dough, tomato sauce, and we already get a nice structure here, and also some additional information. But if we don't just want to have this in form of a string in our application, let's say we want to have a table in our application, then we would need to parse this now and figure out, okay, what are the actual ingredients and what are the amounts? So let's try to get one step closer to a typed response. So we use, first of all, the improved grocery list. So if you see here, we use exactly the same prompt for the system, but we add here an additional thing. You don't provide cooking instructions, you skip any small talk. And let's now have a look. And now we're just getting a list of ingredients. This list is a little different, so I'm just using the GPT-4o Mini. And if you wanted to do this better, you would provide more context. So you could think about you have a directory of cooking recipes, which you feed in as a context to the model, and then you would get a much better list here. But for the sake of demonstration, this is enough. So we're now one step closer at a structured output, but still we would need to parse this. So let's now use some JSON here. As a last line here, we say answer in JSON, and we provide the structure of it. And this way, hopefully, it will provide a list of objects where we have the ingredient and the amount. So let's just run this. And now you see here again, we get a string, but this string now uses our structure. So this already works very well with the models today. So you can ask them to answer in JSON, and most of the time they answer in the way you want. But wouldn't it be nice to get directly an object back from the model? Because we're already using Python here, and we have this Pydantic, which I showed you already for the interaction between a user and our middleware. So now the same thing, model and middleware, we want to also have the Pydantic. So what we can do, and that's important, let's first have a look at the OpenAI API reference. So if we scroll up a bit here to the input and we look here at the request body, if we scroll down, what we find here is, it's a long list first of all, but here we have this tools and tool choice. And if we look at those tools here, they can be a function, which is basically a description of what the function does, a name for the function, and then very important, the parameters. And this is a JSON schema reference. And that's the key to bringing in typing into the model responses. So a tool is basically a function which can either be optional or required, which the model can use. So if you ask the model some question and give it also a selection of tools, the model can decide to call such a tool. And when it calls a tool, it will stick to this setup here. So if it calls the function, it will provide the parameters with the JSON schema structure you provide. And a very simple way to use this tool here is to provide type safety. And this is also a very good introduction on how those tools work. So let's head over to our Python code example again. So first of all, we need a JSON schema, called this here return schema. So that's typical JSON schema. You can just look it up. It's standardized. So what it is, it's an object, and it has one property which is called ingredients list. And what helps here is if you give those elements here, those properties, good names, because then the model will have an easier time to match its output, which first of all is just a string of tokens, to the structured output you define here. Now the ingredients list itself is an array and it has items in it. Those items are again objects, and this is what we defined before. So an ingredient and an amount. And now what we can do with this return schema, first of all, we again have our system message and the user message, but also down here, we give in an array of tools. And in our case, we just have one tool, which is a function. And here we provide the name of the function, validate answer type, description, the last tool to run on answer. So it's the last tool the model should run. And then here, the parameters, this is our JSON schema. And then the tool choice is telling the model what to use. And in this case, you could just give a tool choice, which is kind of optional or required, or you can specify which tool to run. In our case, we want the model to always run the function with the name validate answer type. So this is the match here. We have a list of tools, and here we tell it which tool to run. Now, the answer of the model will then also be a little different. We will not, if you remember up here, access the choices message content. Instead, we're going to look for a tool call under choices message tool calls. And since we kind of require this tool call, we will find it. And if we don't, we could have some exception handling and maybe call the model again. And what we can then do here, under the tool calls, the first tool, because we're just calling one tool, we want to access the function and the arguments of the function. And the arguments will be of the type we defined here. So it will have this exact structure. So this is basically our return type we're looking for. And then we're just going to print it. So let's have a look. And now the result looks exactly as we've defined it in JSON schema. So we have the ingredients list object, and then we have an array of ingredients split up into ingredient and amount. And such a structure you can then easily use or cast to a Pydantic model. But we can do better here, because this is still a lot of writing here. But since we're already using Pydantic, what we can do is in the next step, instead of defining the JSON schema, we just define a Pydantic model here, an ingredient list. It has a list of ingredients. And what we can do, thanks to Pydantic, we can use this ingredient list here under the parameters and just use the model JSON schema. schema. Pydantic will take care of generating the JSON schema for this model we defined. Then we call it again, same as before. We access it same way as before. But what we then do as a last step, we go back from this argument string to the actual type. Those two go hand in hand. So first model JSON schema, we go from a type Pydantic model to a JSON schema. And then here model validate JSON, we go from a JSON string back to the actual type. And here then we have the ingredients list. And now to print it, in this case, since I want to print it, I have to model dump it. Let's just do this and have a look. And it's actually looking the same as before, but with much less code. And those types, typically, you define them anyway. So if you watch my last tutorial, you see we have those types defined for the front-end interaction with our middleware already. And now we can reuse them basically to also tell the LLM how to respond to us. And then we get the full type safety through our complete application from the user, through the middleware, to the LLM and back. And the final step, and this is now where Pydantic AI comes in, we don't need to write all this stuff here. We can directly use Pydantic AI. So we again define our type. So that's the same. So we still need our Pydantic models. Then here we create our OpenAI model. What you could also do if you use Pydantic AI, they have some predefined strings which you can pass in. So Pydantic AI supports different models already. Among those also what we use here, JetGPT-4 Mini. But I always like to do it like this, finding the model. And then we create an agent, and that's the key. So Pydantic AI uses the concept of agents, and you can define a lot of stuff for those agents. One thing is again the system prompt. It's the same as before. And then here the result type. And this is the ingredient list. Pydantic AI then does some type magic to have this all type safe, and MyPy will not complain. But in essence, under the hood, it does exactly what I just showed you in the last cell here. So it will also create the schema and then go back to the actual type. And I'm using the asynchronous mode here. To have it run in the Jupyter Notebook, I need to use the event loop. So I have to first get the event loop, and then I can just run the agent. And here, what I pass in, this is basically the user message. So same as before. And when we now run this, once more, we get the exact same output. This is the essence of how you can use Pydantic AI just to get type safety. It can do a lot more as it's an agent framework. The idea is you can combine different agents, add in additional tools. So not just getting this return type fixed, you can also add tools which are all type safe. So you can easily build complex agent frameworks, and you can do it really here in code. And yeah, you're closer to understanding what's actually happening. In contrast to many of the other frameworks, there are a lot of drag and drop frameworks, which are nice to use, but I like it a lot more if I can write actual code and really see how things work together. And yeah, this Pydantic AI, as I said, currently it's beta, but it's something to watch out for. There's going to be a lot of development, I assume, and I'm looking forward to see what else they come up with. As I said in the beginning, this grocery list, one thing you might want to do is to pass in some additional context, and you can build this up with Pydantic AI. So you could, for example, have an agent which then goes and loads in some cookbook, which you pass to the AI. And this way you get a much better ingredients list. But that's for maybe another tutorial. Here, I just wanted to give you a little introduction and also explain to you how you can get type safety into your AI applications, into your interactions with LLMs. Okay, that's it for the video. Hope you liked it. See you in the next one. Bye.